We are Kickapoo High School and we will be presenting Cereberus Fossae, evidence of volcanic and fluvial processes creating fissures on the Martian surface. The target area is Cereberus Fossae, an area in the Elysium Planitia.
The purpose of our research is to identify and examine primary processes of our region and to provide a geological characterization and mineral analysis of Cereberus Fossae.
Based on the CRISM data, these two fissures are comprised of oxidized iron minerals. Fissures are igneous features that are linear volcanic vents formed due to underlying pressure from a mantle plume rising from one's core and magma flowing through the cracks and crevices of one's asthenosphere.
Just northwest of the target area are a relatively large chain of volcanoes, Elysium Mons, Hecate Tholis, and Albor Tholis. These features are thought to be shield volcanoes. Shield volcanoes are formed from lava flowing on the surface in a slow and mannerly form and slowly build up due to overlying amount of lava flows which give it a low profile but long base. From this data, it is proven that these features are magmatic in origin. We have found immense amounts of mafic minerals and the presence of olivine, a mineral which crystallizes in the interior of a planet, which contributes to the hypothesis of the formation of Cereberus Fossae. Further evidence for magmatic activity in the area is Plutons located to the northeast. A Pluton is a plume or magma chamber that has intruded on the overlying rocks and crystallizes without erupting on the surface. On Mars, we suspect these features to be gabbroic in composition. After a period of time, depending on the area, the crystallized magma is exposed due to erosional processes. From the CRISM data, these features are in fact composed of oxidized iron and ferric minerals, proving speculation that these features are in fact magmatic in origin.
There is evidence of possible bound water in the areas past. Up and around the region of Elysium Mons, northwest of the intended area of the study, there is possible water outflow channels. It is believed that these possible outflow channels are not lava channels or collapsed lava tubes, due to the meandering nature of the channels. Water outflow channels are more sinuous and wavy due to the viscosity of water in respect to lava. Due to the fact that lava tends to be more viscous and heavier than water, lava channels are more straight and direct. Spectral data concludes that these outflow channels contain bound water along with minerals indicating a past presence of water in and around those areas. North of the target area are polygonal faults within a crater. Polygonal faults are a network of layer-bound, large extensional faults that are arranged in a polygonal structure. These faults are an indication of a deep ocean environment and a possible water environment on the Martian surface and show signs of water ice from our data. Due to the layering of the faults in the crater, it is believed that the crater came before the faults due to the concept of superpositioning and shows that there could have been an immense amount of water on Mars after the late heavy bombardment 3.8 million years ago.
In conclusion, there is a significant evidence of past volcanic activity based on the presence of Elysium Mons and surrounding volcanoes. This past volcanic activity is believed to be the force behind underlying pressure that created the fissures in Cereberus Fossae. To the east of Cereberus Fossae are a series of Plutons that were revealed through erosional processes. These processes are believed to have been provided by flowing water. Evidence of flowing and bound water were found in spectra data and features in the area. This concludes our presentation on Cereberus Fossae.